Okay, so welcome you to the last lecture of peer-to-peer networks and applications. Before starting this lecture, I would like to say some words about the procedure of the registration. So most of you, I ask you to participate with the Doodle link to find your appropriate time and schedule, and I hope you did. So the last chance to register is today, and I think you did already. So what I ask you next to do is to proceed with the organization to bring your registration sheet, if I didn't assign it yet, to the secretary of Professor Scheidler. So you find her in the web. It's Marion Bevermeier, and just deposit there your registration sheets. I will sign it. Yes. And if you have any questions to the registration, just feel free to send an email or call. Okay, so let's start with the last lecture. It's about online social networks, and this is one of the probable future applications of peer-to-peer networking. Okay, so what are online social networks? I think most of you are very familiar with it, and probably you also saw yesterday the presentation of the new project groups. There's something similar was also announced. So online social networks, what can this be? So you have your friend relationships, and these web-based networks, web-based portals help you to set up your profile page, to display your likes and hobbies and your friendships, and to connect to other users. And that links reflects a real-world relationship between individuals in a digital manner. So you have the opportunity to link to your friends, to show what you like, and to just exchange information, content, user-generated content, and things that you like. It also includes messaging, like guest books or walls, or emailing or chat. So any kind of user-to-user communication is included. And you can have also lots of collaborative applications. If, for example, look at Facebook and gaming, and you have also not just Facebook, if you think of it, but also there are thousands of other social networks which target different kind of audiences, both for personal online social networks, but also for public and professional online social networks. So there's a wide set, and it's a very popular topic nowadays in the internet. So just showing you some examples of the target audiences. So I think Facebook, that's this one. That's more for personal connections. Then we have something like Xing or LinkedIn, which is more for professional oriented users, which display their professional opportunities, what they can offer. Something like Twitter, just exchanging information. There's something like a Doppler for business trips or meeting services. There's also social networks for sports clubs or for any kind of community that you can think of. So it's very popular and upcoming. And why is it relevant? So why is it now a special trend that wasn't before? The point is that it's really reaching almost everybody worldwide. So Facebook traffic topped Google. That was 2010, so Facebook is generating most of the traffic worldwide. And also looking at Twitter tweets, it's going to become 10 billion a year. So it's really fastly growing, and Facebook is set to reach 1 billion people this month, next month or so. So it's really reaching a very large fraction of people worldwide, and there's a lot of money and lots of interest for everybody inside. And also if you look at the typical usage count per website, so this is some rank for January 2010, so that's even 2 years old. And if you look at which are the most popular websites and how are they used, you see, okay, Google is most used, so most of the unique visits based on Google, but the time per person being online on the sites is 7 hours at Facebook, and that's something that's not even touched by the other websites. So Facebook's very popular, and is going to it has really a big impact on everybody's life nowadays. Okay. So we are talking about online social networks. So what are the goals and motivations for the users and providers? So if you look at social networks, Facebook and similar, what the users really want to do, they want to store and search for content. So their profiles, their friends list, their pictures, shared wall edits. So they really want to communicate with their friends via some content, via direct messages, via exchanging pictures. And they also want to have this user-to-user interactions with like chatting, voice over IP, or games, direct games between each other. And what they also want to have the users in social networks, they want to have security. So they want to be sure that they can define who has access to their data, and that their communication is secure and confidential, and so that everything that they do between their friends is somehow secured. So summarizingly, they want to have secure fun. And the system providers, the Facebook company and all other companies who provide such online social networks, what they really want to have is high profit. So they really want to have as many users as possible, to have personalized advertisements, to make money with them. And that benefits they want to have best would be for free, so low operational costs with so the operational costs they want to minimize basically, but they have servers, they have to pay for electricity and cooling, personal and legal issues, and they also want to provide a controlled quality of service to really make sure that, for example, Facebook is performing very well and it's reliable and the data is always available. But concludingly, they want to make money out of it. And this is somehow a contrast, because in order to really make money, you really have to get access to the user data and to find out what the users want, and this is not what the users would like to have. So there's a contrast in these two requirements. Also, if you look at the security issues that we have in online social networks, I just want to introduce some terms because they might become relevant later on. So what you want to have is that your data is always available. So the profile pictures and friendship graph that you put in should be always accessible, although your friends are offline or you are offline, and that's something I think normal already to accept. Also, privacy and confidentiality. So you do not want other users. So differently. So you want to define who should have access to your personal information, to your pictures, to your friends list, and you want to really define these privacy settings in a quite advanced manner. And what you also want to do is to be sure that only you are able to modify or change your content and not somebody else by hijacking your account or modify something in a way that you do not find appropriate. So I think these are typical requirements, and they are for sure implemented and realized by Facebook and all the big companies. So that's nothing that you are surprised of. But if we look at, so just continue how the centralized social network systems work. So typically what you have is that on the one side, so where do we start? So we start, for example, on the user plane. There you have the friendship context, and you have relations, trust relations, and you want to have different kind of communications. So offline, so over a specific storage, let's say, where you write in some blog entry and you get out, and you can also read it. So you can write a comment, somebody reads it, or you have this real-time communication, conferencing, internet messaging. So this is the minimal set of requirements for a social network, let's say. And in order to implement it in a centralized way, you have the several servers performing it. So you have this is first the participant's device. That may contact the social networking server. In the background, there are various databases and also other application servers. For example, if you are playing Farmville, then your data is also, so your program is also executed on third-party application servers. So you have here this server plane, and below, of course, there's this communication network, the internet. So I think this is not very spectacular, but just to keep in mind what kind of services we have. If you look now at these centrally hosted social network services, we see, of course, okay, it's easy to really have a centrally hosted database, and all users might access it. Of course, you might have this database distributed, but it's all under your control, and you can implement some very clever mechanisms. The provider benefits out of it, so he has the data directly accessible for marketing, so he can really see what the users like, what they don't like, and to spread his advertisement. But the problems are for the providers, so it's said to be that it's very costly. So if you have, for example, 1 million users and they do not pay anything, like in Facebook or Werk.Ing or StudiVZ, the question arises, so how do you finance all these the provision? So is the advertisement really paying off? So it works probably for Facebook, although it was already... So I know for Facebook, for example, there are some measurements. They say one user costs $1 per year. And if you have 1 billion users, then it costs you quite a lot of money to provide to operate. And it was also said that Facebook only turned profitable with having 500 million users. And it's really a big number. So if you have a smaller social network, for example, I don't know, for Paderborn or for the university or some just smaller scale, or even Werk.Ing or some more local social network, then the question is, does it really pay off? Because you need the money to operate all these servers. And for the users, do you really trust the provider? So if I post my picture on Facebook and I delete it later on, is it really deleted or only deactivated? Is it still stored somewhere? Do they still use my data or not? I cannot see it, I cannot touch it, so I have to trust, but I'm not sure whether I really trust. Also, what you can do is typically that you have only a limited application scope, so you do not have really this user-to-user interaction, like, for example, a voice chat. I hope it's still correct. So in Facebook, it's still not possible, although it's a very convenient feature, like in Skype, to just have this user-to-user calls or video communication or whatever. So it's everything over the servers, and it's introducing some delay. It's not very user-friendly. And typically, it's really the problem. So if you have a big community where everybody's inside, like Facebook, then that's really probably a too big community that you do not want to have. So if I really, for example, want to have only a small community just for you, for example, to share my lecture slides, it's hard to set up. It's hard to pay it, and it doesn't really work well. And if it's too big, then too many people have access to it. Okay, so concludingly, of course, and because it's a lecture, P2P networks and applications, we are asking the question whether this can be decentralized. And what parts can be decentralized? So first of all, something like the data storage, the control, so that means the operation of the system, access to the data, how to find the data. So it's all something that needs to be decentralized, and especially to take away the central point out of these elements. So the data should not be stored centrally with central access by the Facebook company, for example, and it should not be controllable by the service operator. So we really ask the question, can we take out these data and do it fully decentralized and support with that re-democratizing the web and all that kind of philosophical approaches. Okay, something more technical. So there are already some approaches how to do it. So let's say there are 4 larger areas how to have decentralized social networks. So first of all, friend of a yes. So it should be FOFS. So friend of a friend system. So the idea is that you have contacts, so that you create basically a web 1.0 kind of approach, that you set up your own web server and you connect to your friends, and with connecting the friends of the friends, then you have a social network, and there are several approaches going into that direction. Also, there are some commercial approaches that are really trying to introduce a decentralized idea in social networking. First of all, diaspora got very popular, I think, in 2008. It was that was very funny story. So 4 New York students announced they are going to implement and code a decentralized social network if people are paying them, and they got $200,000 just for this proposal by Kickstarter, by this crowdfunding website. And at the end, I think they just delivered a buggy code, and it was just a student project, but they got quite rich with it. Recently, one of them died, but that was independent of these actions. And there's Voila, that's similar to Boxnet or Dropbox. Some of you probably heard of it already. That's also something that you can share some of your storage space, and yeah, like Dropbox, have it always on, always accessible, and you can also share some storage space with your friends. There are some academic approaches, like friend of a friend, Hello World, that was I think from Kassel. So lots of Pearson is from Stockholm, and they are all trying to create a decentralized or peer-to-peer based approach, but as you know, nothing really popped up to a real product that can be used. Not yet. Okay, so when looking at this decentralized social networking approaches, what we will look at is how this social networking and decentralized approaches can be implemented, what kind of functions they are, how to have a running software, and what is really the decentralized aspects about it. So just some further words. So this friend of a friend, that was this more Web 1.0 with your own web server. So you have your own web server, you link it to your friends, you create some yellow pages or some Telefonbuch, similar things, so that you really say, okay, this is my web server, this is my profile, and these are my friends, and I put some links to their web servers. And so you store your own data, and you trust your friends' web servers, so maybe you can also store your data there. But do you really have a web server? So, and at the end, it's decentralized because there's no central instance where all the information is. But it's really hard to find some content that you are looking for, to find some new friends. And most of the people do not have own web servers. It's hard to implement, and you do not have this user-to-user interaction. There was this Hello World network. They also won some startup prize, but they followed the same idea with the web servers. But I think after they won that prize, that was stopped. And yeah, that was Diaspora in 2008, where they really got lots of money, and they just initially wanted to have $10,000. They said if during the summer they don't have to work, and that would be the amount that they would earn as 4 persons, $10,000, then they would implement, they would use that time to implement the code. And it was really similar, also like this friend of a friend, with your own web server, so very static and very hard to configure and to set up. Okay, so of course we are looking now, can this be done in a peer-to-peer based fashion? Because the idea is, do you really need your web servers? Because if you have your devices, your typical devices that has sufficient storage space, sufficient bandwidth, and if it works for file sharing, probably it also works for social networks. So what is the motivation? So first of all, just comparing the server capacity worldwide with the the PC capacity worldwide. So let's say in the last 4 years. So there's really a big, so this is really in scale, I think that's 1 to 50, the relation, and there's really a sufficient number of user devices that could be used to provide that social networks. And if you really think of Facebook with 1 billion people being in that social network, so there's also so it just seems to fit that there are sufficient number of users, that they have strong enough devices, and that they can host the data by themselves. So what would be the benefit? So you could host your own community. So if you would have some peer-to-peer application, like let's say Skype for social networking, that you could download, create your own network with within the university, for example, or within your family. So you could have your own community. You would be able to keep control of your data, to implement mechanisms that make sure that only you can access the data and the people who you give access to. And you could have this cool applications with real-time interaction. So because if two users are online, they could really interact in real time with each other. So what are the challenges? What should be done? The first of all, what such an approach needs to consider is that it can only use, of course, the user devices to create the infrastructure, no servers required. And the question is, what kind of what kind of research results are existing? Is the quality good? Are they really combinable? Because some problem is you cannot, if you create a solution from scratch, then you also have a lot of problems that previous research already solved. So best would be to reuse lots of research results and then just to append it to and extend it to become a social network. So we will see during this lecture two versions and how this can be done. Okay. So what should be then solved? So if peer-to-peer online social networks are the goal, so what should be what kind of challenges are going to be encountered? First of all, performance is a big issue because peer-to-peer was typically used in file sharing applications, and this is that you have big files. For example, in BitTorrent, most of the files are movies or very large ones, comparable, and there you have always some users online who are interested in that data. So, for example, in very popular movies, there are always some users who share it and who are currently sharing it, so that if a new user comes, there is already a set of users who are actively looking for it. But in online social networks, you have only small and short-lived objects and typically very unpopular. So your personal profile picture is very rarely interesting for many people, so only for your friends probably. And you have extreme heterogeneity in the content. So both the number of friends is very heterogeneous over the users, the uploaded content, the size of the content what you have, and the resources. Also, the user behavior and sessions are very different to file sharing. And yes, incentives. So in file sharing, it's somehow also clearer why people should contribute and cooperate just to have their files. In social networks, it's a little bit more difficult. And looking at the security aspect, so question arises in these challenges. So how can we really guarantee that the data is available? How do we make sure that it's also quickly retrievable? How can we search for somebody and also for specific groups and pictures and any kind of content that we are looking for? How do we manage the security and the crypto keys, for example? How do we manage identities? So lots of questions to be addressed. Okay, just one more slide on summarizing the requirements. So just to clarify where the differences are also in comparison to file sharing applications. So typically the functionality is not like in file sharing only related to data, to store and retrieve data, but you have really complex applications. What you want to have is you want to have something like Facebook with the full functionality with profiles and pictures and groups and friends list and walls and everything that you can think of. And you would be to have it very extendable through apps or plugins, so that you can also introduce new functionality. So best would be somehow a general platform that can host all of this functionality and that is extendable out of the box, also provides this app functionality or app market. There you then further looking what kind of basis requirements you need. You need some data access patterns. Of course, you should be able to read the content, independent whether your friends are online or not. So you should be able to download their profiles and friends lists and whatever they host. You should be able to write new content. So this of course, you also have a file sharing to read and to write. But for example, updating is something that is not typically available in file sharing. But what you here want to do, you want to really find all copies of your data that you want to update and to consistently overwrite it or to update it. Typically in file sharing this is not really doable. And even more complicated is deletion. So you want to really securely remove data and be sure that all the content related to that entry is removed, even if the nodes are offline that are currently storing it. So it's very complicated. Okay, what we further have in social networks is, in order to support these friends list and group lists and pictures and profile data, so you need some distributed data structures in order to support all of these various applications. And that also should be matched to the heterogeneous peer capacity, so they have different kind of storage space and bandwidth, and also there are different kind of data access patterns. So for pictures, probably the access patterns are different than for group entries. Security is a big issue, as it was said. So what is the root of trust? How can we manage the user identities? How can we have this confidential communication? So these are all aspects that are irrelevant for file sharing, and that also needs therefore new solutions. Also access control. How can we define that only the friends that we have the read rights for our profile picture, for example, or only that we are allowed to write in our wall or to change our status. So how can we all implement this? And then quality of service. So that's also an issue. How to monitor it so that everything's working fine and that the lookup times for the profile is below 1 second, for example. And there are several hands-on challenges how to implement it. So very far longer list than for file sharing. So file sharing is very much easier. There you do not need to trust anybody. There you just download or upload your files and that's it. And you do not have to have user identities. You don't have to have distributed data structures. It's very simple in comparison to online social networks. Okay, so we will have a look at two solutions. And first of all, the first of it is a SafeBook. It was implemented and supervised. There are two teams. One is in Darmstadt by Professor Thorsten Schufe, and the second one is I forgot, but it's in France. So Eurecom, yes, good. Okay, and the main idea is so this is basically creating a new overlay from scratch that directly supports online social networks. That's the idea. So what is how does it approach? So what you have a new overlay, and you have only your friends in the overlay as your neighbors. So your direct contacts in the overlay. So if this is you, then these are your direct friends, and these are the friends of their friends, and these are their friends of their friends. So you have the social topology that is the social network that is reused. And with this approach, you also have some security features, because of course, it is assumed that you trust your friends and they do not misuse your data. So you can also store your data on your friends. And just because of this trust relationship, you have some advantages. We will see what the problems are. Some problems, just keep it in mind. Keep in mind the question: what is about the performance, and what happens if you have only a small user, a small friend count? So it requires a large friend base per user to operate. But we will see how it operates. So okay, what are the assumptions? So first of all, it should be decentralized. And how is this accounted for? So the idea is, with your friends, you cooperate, you like your friends. So if you cooperate with your friends and everybody cooperates with his friends, then at the end, everybody will cooperate. And by using the friends relationship, the trust between each other can also be used. So this social trust results in trusted links, a trusted topology, and then the friends, your real life friends, are becoming your neighbors in your topology. And it's also then easier to implement privacy, to have a simple anonymous routing based on trust links, group encryption, and these features. Okay, so how does it work? What is the architecture? So first of all, you have to think of so these matryoshkas. These matryoshkas, this is the synonym for these Russian puppets that you can put in each other, and this is somehow the analogy. So this is you in the middle. This is your inner ring. That's the first. These are your friends, and the second ring is their friends, and you have these rings. So this inner rings and outer rings, and even more outer rings. So you have this these rings around you, and these are called matryoshkas, and they are used for data storage and cooperation and privacy-aware communication. So how do you organize now these matryoshkas? So every user has this kind of structure, and in order to enable the lookup and to find corresponding users that you're looking for, you have a peer-to-peer substrate, a DHT, and the matryoshkas are somehow matched to it. And the third instance that you have a trusted ID system, so that's what they assume, so that there's some trusted third party that matches the IDs, so that assigns to you, that makes sure that the ID that you use here is also the appropriate one used there, and that you don't have too many random new users that are not validated. So every user needs to be validated, and to be made sure that the user in this ring is the appropriate one in that ring. So just that there are not too many unknown identities. And the authors say it's not a contrast, so it's still okay to do so. It's a required assumption. Okay, so how does it work? So first, okay, you have the internet, then you have your typical DHT, and then you have a social network overlay. So, for example, just to give you an example, if one user A wants to communicate with user, no, not to communicate, but if user A wants to download the profile of user B, he has to somehow use the peer-to-peer overlay to find an entry point. So that means one of the outer nodes of B, for example that one. So first he has to find an entry point for B, and then the request is routed to B, there the profile is retrieved and routed back over the same route to A. So this is these are the various layers in SafeBook to implement the social network. And you have also the various IDs. So you have here user ID that you can look for. The node ID is a little bit hidden, and the IP address is also hidden. But one of the goals that are achieved is that user A does not find out the IP address of B. So B is hidden from A, and also A is hidden from B. So B doesn't find out who's contacting and accessing his data, because in this region all the communication is somehow made privacy aware. So all the information about B and A, so the contact information is lost. So B doesn't know who A is, and A doesn't know where B is. Ah yes, and these two are linked. Okay. So how does it work? Again, so this is node I. For example, your own node. These are your friends. They store your encrypted profile data. So them you trust. So you assume that they do not change your data. So they do not change your data in a way that you do not want to have it. So it's all encrypted and stored at your friends, and you trust them, and you have this trust relationship. So you also keep contact to them in a topology. And this is called your inner shell. And then you have this friend of a friend approach. So this is D is a friend of C, and they have a trust relationship. And but this trust relationship is not transient. So D is a friend of C, C is a friend of I, but you are not a friend of D. So this is not valid anymore. So you do not store your content on D. So your content, your profile is only stored at your direct friends. Okay, and if you continue that approach, so C also has his topology. And this is, for example, the view of I, and he has up to several rings. And so in this case, it's 3 rings with a splitting factor of 1. So it's not split at all. So every friend has only one more friend. So it's only directed lines. And so this is the inner circle where everything is stored, and the outer shell where the access points are. So this is called in total the matryoshka. And the question is now, how do we get to these entry points of the node I? And for that, the peer-to-peer DHT is used. So in this case, A looks for B. Therefore, this is A on the DHT. And it has somehow some knowledge about B's name. So let's say you might hash the entry B's entry points or whatever. So just to have a clear key under which you find the entry points of B. So for example, in this case, A starts a lookup for B's entry points, and K might have the information about the outer shell of B. So the lookup in the DHT progresses, and the outer shell, so the entry points, are found. It should be, I think, direct, but it depends on the DHT. But however, A gets the information about the outer shell of B. So step 1 is done. Very good. Okay, second. So now A knows, okay, E and F are entry points for B. So he also starts a lookup for E and F. So in this case in E. And E is corresponding to the entry point, and now we can use this entry point to look up the profile, for example, of B. And now E knows the next step towards B, but not more. And it doesn't, so it just forwards the routing request to D. So A doesn't know that D is the next hop, and it follows on. And the profile, for example, of B is stored at his inner circle, so at his direct friends at C. And once one of these inner circles is reached, then the answer is propagated back, and A knows now the profile of B. And here we see also the security features. So some of it, first of all, during this steps in this onion routing, the identity of A is not revealed to B. So they only have to, for example, if the request is coming in, they just have to know for which request number they took which next hop, and if the answer is coming back, then they know where to progress it back. So A's identity is hidden, and B's address is also hidden, and B might be also offline, so because it's assumed that one of his friends is online, and they might answer with the correct profile information. So what kind of roles are there? So again, the peer-to-peer system is, so if the node of one user is asking for the content of another user, then the peer-to-peer system is used to find the entry points. And using the entry points, now after this onion routing step, you might retrieve any kind of content from the user. So the benefits are, you hide a requester's ID, and you also hide the identities of the friends of this matryoshka nodes. So that's a bit wrong here, I think. So it's not hide identities, but it's the nodes in the matryoshka are hidden. So it's also not known to user 1 who is inside here. And also for user 2, the request statistics are hidden. For the integrity, you cannot also forge messages in the name of somebody others. So user 1 cannot claim I'm user 3, for example, and I want to have the data of user 2. So it cannot be done because the identities are really enforced. Yeah, and that's why you cannot manipulate it. You cannot also have this distributed denial of service because you cannot take down user 2. You can only take down his matryoshka or his entry nodes or so. The trade-off is, however, you have low delays because this step over the matryoshkas with several hops, and every hop requires 100 milliseconds, let's say, that takes time. So you have to go there. So if you have here 4 steps, then you have to take 4 steps there, and then 4 steps back again, and there's no shortcut in it. And also, if you look up key redundancy, you always need to look up for the entry points, who's online, and so you have also a lot of lookups. And another drawback is if you transfer the profile or an album, a picture album of the user, let's say it's 1 megabyte big, then you have to transfer it 4 times for every hop in the matryoshka. You have to transfer it. So it's really generating lots of overhead in retrieving data. And I'm personally not quite sure whether this is really a really interesting feature to reach for privacy. So if I'm in Facebook and somebody is accessing my profile, is it necessary to be hidden to me, or is it necessarily that somebody finds out where my data is located? So I'm not quite sure what these privacy goals are aimed at, whether it's really that killer feature that was required in Facebook. I don't know. Okay, so however, the authors of SafeBook say they have several features included. So privacy is done because you have this friendship relationship, and it's also the friendship relations are hidden through the matryoshka. So in your inner shell, your inner circle, that information is not really transferred to the outside. You only have, after several rings in your matryoshka, these entry points, and they help. Really, this onion routing helps to have anonymous routing, and you have this pseudonymity, so you can also choose different kind of routing paths. So you have some privacy enabled, both for the requesters of data, but also for the providers of the data. Cloning prevention and DOS denial of service prevention is managed through the ID management, because every node is identified. You cannot create too many unreal nodes, so the Sybil attacks, and you keep this controlled. And access control is managed through key management because you trust your friends. You can also tell them to whom to give your data free, and they can implement it. So it's easier doable. And for the availability, data replication at friends node. So if you have a large number of friends, then you are good. If you have only 5 or 10 friends, or you do not want to keep too many friends, then it's a question how do you do it then. So I'm not sure what happens when you join the network for the first time and you don't have any friends. So who is your matryoshka then? And what do you do if you only have 5 friends and they are all offline? So can people find your data or not? That's a little bit unclear. Okay, what they also evaluated is, the question is, how many contacts, so close friends, are required to be reachable by 90% if you want to have 3 to 4 hops in your matryoshka. So if you want to have 4 circles, and with that very robust and secure onion routing, then so that means this is the goal that you aim at, and you want to have an online probability. You assume an online probability of 30% of the nodes. Like there were some measurements in Skype that show that out of all nodes, only 30% are available. Then you need 80 to 250 nodes to really be able to create a matryoshka with in which all of your nodes which makes you reachable at 90%. And if you somehow have some relaxation in these requirements, so for example, if you that was spanning ratio of 1, that means every friend has only one outgoing link. But if you increase it so to look like this, so that every of your friend has 2 contacts, I think that should be attached there, then it's okay to have less friends, so to have 3 to 4 hops with a spanning ratio of 2, there you only need 15 to 25 contacts to be reachable by 90%. So you still need some number of friends, and also this reachability by 90%. So I'm not sure whether this is really a good goal. So if I'm only reachable by 90% in Facebook, that's probably not very favorable. So I would like to be reachable by 99%. And if I then think of how many friends really need to be online, how many friends I need, I think that really goes up to more than 100, even if the spanning ratio is 2. Okay, something about the performance. So we saw if you have this various hops. So on the first, you want to have a high number of rings in order to have multi-hop routing towards you, to have this privacy goals. But on the other side, by having this multiple hops towards you, also the delay increases. So this is a 4-shell matryoshka, so with 4 rings. And the question was, how long does it take for a first lookup to contact the node or somebody who has information about a specific node? So if somebody would like to retrieve your profile in that matryoshka-based system, then the first lookup requires in average 9 seconds, and in median 8, and 90% of all requests are handled within 13 seconds. Because first you need to do the lookup to find entry points. Then once you have the list of entry points, you need to do a lookup to those entry points. That also takes O log n, so you need already twice O log n of requests. Then once you got to your first entry point, you need this multi-hop routing, in this case 4 hops towards the inner circle. Then you need 4 hops back, and then only you retrieve the data. So it takes in average 9 seconds to retrieve a profile picture, and I think this is, so in my personal opinion, this is very long time. So if I would click on a profile picture of somebody and I have to wait 9 seconds, that's not a very nice user experience, I think. Also, if you so this is the case once you already have the entry points, that part you can skip, and you only contact any entry point, and then you have this multi-hop routing there and multi-hop routing back. Still, the average is about 3 seconds. So also that takes some time. And if we now think of that you really, as it was said, you want to download an album of pictures and it requires 1 megabyte. In a typical DHT, you would send your request and you would get the file, and in total the traffic generated is about 1 megabyte plus a little bit for the first lookup. In this case, the traffic generated for retrieving 1 megabyte of pictures, for example, would be you first start your lookup, then it takes 4 hops to get there, and then the picture is transferred from your inner circle to your second circle, then from your second circle to your third circle, then from your third circle to the fourth, and then from there to you. So it takes 4 megabytes, so it's for every shell that you have, the traffic is multiplied. So it's really a large number of traffic generated, and if you think of every downloading 1 megabyte of data takes some seconds, then it takes even more if the data is large. So summary, SafeBook, it matches the peer-to-peer topology into the social topology and creates these kind of matryoshkas where you also can assume the trust relationship. So you have your social storage on trusted friends.
But performance may be an issue because through the onion routing you have typically a really high delay, and the retrieval of pictures and of any larger files generates multitudes of load and delay through the onion routing. Also bootstrapping problems I see, so how to handle users with only a few friends, and what if all of the friends are offline? Is your data then lost? So it's somehow very harsh assumptions to make and difficult to really set in place. And also, do you trust your friends? So everybody who has friends on Facebook probably knows that I do not really want to store my data on on every of them. So they are friends and they are friends. Okay, so nevertheless, that's a very interesting attempt to create a peer-to-peer based social network, and hopefully it gets successful soon. They are also implementing a prototype, and they have several publications on it. We will see where this leads to. Okay, another approach, and this is more the one that I'm more familiar with because it was started as my work. So since 2007, lots of students working on it, many peer-to-peer research applications implemented. So the idea is to really also another word to SafeBook. If you had a look, they provide a social relationship and friendship and plugins, but that's also very limited. So I'm not sure how to implement groups that's independent of one single user. So if you would have a group for Paderborn, for example, all members of the University of Paderborn do want to create a group. I don't know how to create it in SafeBook. In Live Social, nevertheless, the idea is to really have the Facebook-like user experience. To have basis functionality like friends and profiles and groups and emailing and everything that you can think of. And it should be extendable through plugins. So not just a limited set of features, but also unlimited and nice things. Okay. And what you want to have is basically two approaches, like we also saw with the centralized social network services. You want to have data-centric applications like a wall, a forum, a blog, or profiles that you store and somebody else looks up. And you want to have this user-to-user interaction, chatting, and video, and all that. And of course, security should be integrated. What we also wanted to have is to have an operator view. So we assume that still, even if you have a decentralized social network, you would like to have somebody in the background who is interested in it running. So you want some operator view that keeps control on the quality of service. So is it working well? That somehow can take actions to improve the things and the running performance. And okay. And it's also very interesting to have a basis to integrate new research and to solve these new requirements. That's very challenging. Okay, so what is the main idea of Live Social? The main idea is that you have first a general peer-to-peer platform that integrates lots of useful modules. That means for storage, for messaging, for security, caching, app hosting, multicast, pub/sub, distributed data structure, monitoring, self-adaptation. So you see, this is all independent of social networks that can be also used for any kind of peer-to-peer applications, let's say for gaming, for example, or for this peer-to-peer based Wikipedia. It's very useful in general. And then you have on top of it, in so-called plugins or apps, the social specific applications that make use of these framework modules. And there's also a graphical user interface that supports that you have various applications, so it's not very strict. So you might, with every app, with every plugin that comes into the game, your graphical user interface should be able to manage it as well. What kind of security goals are there? First of all, access control secure storage. That's one basis. So you really want to be able to define who should have access to your data and that only you can change and modify your data. And you want to have also the secure communication so that it's encrypted and confidential and nobody can overhear it. what we didn't aim at is too much privacy. So for us, it doesn't matter whether we find out who is looking for our data or whether somebody else finds out that we are interested in his profile. So this is not something that is very interesting for live social. And there are no trust assumptions. So anybody might be bad, and we do not trust our friends. We do not trust our direct contacts. So anybody might be malicious in this in live social. Ah yes, and I think that we had already for the users it should look like Facebook, at least from the functionality, and for the providers there should be some quality monitoring that tells how well is the application performing, and that you can take effect and somehow tune the performance of the running peer-to-peer system. For those of you who had been yesterday at the presentation of the new project groups, you might be familiar with that slide. So this is how it looks nowadays. The prototype of Live Social. So you have this GUI framework from Eclipse that you know from programming. So you have all these little windows which implement individual plugins. So this is, for example, profile plugin, the picture plugin, the friends plugin, the groups and chatting and emailing. So, and you can reconfigure it and shift it around, and you can close individual plugin views. So it's really the GUI framework from Eclipse that you are familiar with too if you're programming Eclipse. This is something else. So the pictures, again, here's some emailing, and this is some bigger picture that is presented. So this is the view for showing the photos. There's also friend graph hidden. So this is the so you might also have different views for the same information. So we had this was one friend graph. Here I only have 3 friends. Here I have 4 friends, and just a different representation. And you can open it. So this is how the graphical user interface looks like. So it really supports the various plugins that can be implemented. Also for the provider view, what is inside? So it's probably familiar to you. It's all of these results from monitoring and managing peer-to-peer systems have been implemented in Live Social. So you are able to monitor the statistics. So in this case, for example, the number of nodes and the bandwidth consumption. And we also aimed at implementing this control loop so that we can reconfigure the system during the runtime. And here no personal information is included, because anyway you aggregate the data, so you aggregate the bandwidth consumption, and there's no privacy related information. So the aggregated bandwidth usage of 11 nodes is in this case 1.5 kilobytes per second. Okay, I mean that doesn't reveal anything about the users. We found that this is an appropriate way for collecting data without being privacy harming. Okay, so how does it work? So just a reminder, in contrast to SafeBook, in SafeBook they had this new overlay from scratch. We aimed at the other side on reusing lots of modules and to create first a general peer-to-peer platform or framework, so to say, and only have dedicated smaller plugins for the social application. So, but the general peer-to-peer platform is very general. So it starts with a structured peer-to-peer overlay. Basically down here it's pastry, and it enables the ID-based routing. So we can find contacts via their ID, and we can retrieve and find content. What we also did is, we will see later for the security part, is that we enabled authentication. So there's an integrated public key infrastructure. We will see how. On one top higher above, you have the storage, secure storage and access control with PAST. So PAST, like we saw in the lecture on replication, makes sure that your data is replicated and quite always available. And using the public key infrastructure, we also encrypt all the data that is stored. And there's a secure message dispatcher. So basically this was the storage before, so that you have the secure storage which is also replicated, and on the other side you have the message. This is something like messaging between
first of all the general peer-to-peer platform on one device and on another device, and that you have also this plugin to plugin communication. So like in TCP, that you have your ports, so that further applications on top can communicate with each other over a message dispatcher. And if a message arrives from bottom, from here somewhere, then the message dispatcher checks, okay, my profile plugin wanted to have this data, or my friends list wanted to have this data. So it enables this plugin to plugin communication. And because the cryptography is below, you have this encrypted communication, authenticated integer, and you can really check that it has not been modified. Yes. And this offline messaging, that is something, if the user is offline, the data, the messages are stored in the network until he gets online again. Okay, and on top of it, what is further inside is that we have a cache. So the cache helps. So for example, if your application wanted to retrieve the profile pictures of your friends, it's cached there, and the next time it is requested, it can be automatically delivered. Of course, it might be outdated, but for the user, you directly have the new picture, and you can display it, and below you can, in the meantime, request a newer version, and make sure that the next time the picture is refreshed, then you have a newer version. So it just helps to get quicker results, have to hide the asynchronous effects of distributed data storage, so its content is instantly available. And yeah, this monitoring management that helps to monitor and control the system performance. And at the end, what you have there is to have, beside this core functionality of the peer-to-peer framework, you have all the social plugins that implement the friends list and pictures and groups and messaging and everything. So that is hidden. So they are, yeah, in this plugin plane, and yeah, every individual plugin might either communicate with a shared storage, so with the storaging, with the distributed storage, or via messaging with the plugin ID based messaging. So for example, the chat uses the messaging, and it sends a message to another device, and then it's just forwarded to the message plugin at the other node's application. Okay, yes, and the GUI framework that we also saw, so it's very nice. It's extendable and flexible, and you can add new GUIs for new plugins, and you don't have to think of where they can be placed. Okay, so the communication principles. So as it was said so how is it then technically done? So first of all, the storage. So in FreePastry, that's an implementation on Pastry, which is a DHT like we saw in the lecture, and it helps to really map the document IDs to responsible peers, and then we can store it somewhere and retrieve it. So that we saw how it works. And with Past, we also have the replication. And then you can create distributed data structures. Like for example, this is a shared item with a specific storage key, and it has a pointer. It's for example a profile, so it has a storage key, a header, and a user profile payload, and some information like name, email address, city, and also a link to a profile image. And under this new key, the profile image is located. And you have this plugin-to-plugin communication over the message dispatcher. This is really like the ports in TCP or UDP, that a user A might send a message to a user B with the plugin ID that he wants to address, and the same. So either through the storage or through the message dispatcher, plugins can communicate. And some typical data structure, this is for example for the user albums. So if my username is for example Alice, then I create a storage key through obvious storage key. So there's a strict rule how to calculate the key for the
user albums of Alice, so you just concatenate user album, some strings, and then album. Then you have the storage key, and under this storage key, so this is the content that you retrieve, you have further pointers. And for example, the list of user albums, and user album A has a specific storage key, user album D has also storage key, and there you have further pointers to images. So you can really have this pointer structure in a distributed data structure mapping. And with that, you can really have high granularity of stored data objects. You can really build any kind of distributed data structures. Yeah. And this data is then totally distributed on the network, so you do not have control on where it is stored. So your pictures are stored somewhere, it might be anywhere in different continents. It's replicated, so you do not have control on it where your data is stored. Of course, this is some critical aspect because security issues might arise. But for that, in order that even if you do not trust the nodes where your data is stored, you need to have some security aspects are integrated that make sure that those nodes who have your data cannot read it and cannot change it or modify it in a way that they want. So you have to enforce this access control rights. So how is this access control then integrated and enforced? First of all, if you create some security solutions for social networks, P2P based social networks, first of all, they must be very easy, fast and good. So, of course. But this easy deployability also means that your security solutions must not interfere with other kind of mechanisms. So, for example, with replication. So, replication should work independent of your security solution. So what you want to have is to have the secure communication. So for all plugin-to-plugin communication should be confidential. That means encrypted, authenticated. It should be verifiable who sent the data and who receives the data, and it must not be modified on the way. And for the access control, we have the requirements that as we store sensible information, your profile picture and friends list in the DHT, and you do not trust anybody there, you still have to make sure that only authorized users are able to read your document. Even if the storing node, typically the storing node is not allowed to read your data, but he must store it and he must forward it. And for the integrity of authentication, the author must be somehow verifiable so that the content integrity can be checked. So that means the content must be somehow signed and the signature must be verifiable. False authorship can be then detected with it, and data objects needs to be signed to detect modifications. So that are all the requirements. And as I said, for this easy deployability, the requirement is also that the data must be replicatable. So you do not want to enforce where the data is stored or who is storing your data or who is not storing it, because if you have this layered architecture and a framework module, then it might be that for the next iteration you have a different kind of replication structure which performs better, which keeps your data better and available. Then you do not want to rethink your security solution. So replication should be working out independent of your security solution. This is also something that we saw on the security lecture. So also this knowledge was introduced in Live Social because very practical. So what is done in Live Social? You take your username and passphrase and create your private key. So that helps you to create. So at any PC you can do this. So it doesn't have to be your local device where you create your private key through your username or passphrase. You do not. So you can also sit on some public internet cafe PC and log into Live Social. And the node ID is set to the user ID, is set to the public key, and it really helps because this public key can be used for encryption, and that helps really a lot. So for the secure communication, that were the goals: confidentiality, integrity, and authentication of the author. When we send a message, we sign it with our public key, so of the sender, and we encrypt it with the public key of the addressed peer. And once receiving the message, only the addressed peer can decrypt it, because only he has the private key corresponding to the public key. So only he can read it, it's authenticated and also confidential, and the receiver can check the signature of the sender. So he can also check this signature and verify that the sender is really the one who claims to be. And second, this is how it mainly works. In practice, what is typically done is you do not always encrypt with the public key the message, but you introduce pairwise for every friend that you have and every contact person some symmetric shared key that is first exchanged securely, and then you use that later on. But for the main idea is basically the one with the asymmetric keys. For the secure storage, how does this work? So again, here the results from the security lecture of peer-to-peer systems is reused. So let's call the unsecured data shared item and the secure data encrypted item. Then this is how it works. So let's assume you have one data that you only want to share with your family members. Therefore, you create a new symmetrical key, and you encrypt the data with that symmetrical key, resulting in this data called data encrypted. Okay, then you pick the list of privileged users. These are probably of your family members. Of course, it can be also something else. And you retrieve their public keys. So it's assumed that you know their public keys because you know their user IDs, which is their public key. And then you encrypt the symmetric key with every public key of the privileged users. So you have the encrypted symmetric key for every user. And then you append every encrypted symmetric key to the encrypted data. And then you sign it. And then this is basically this appending of all data that is relevant is your secure data, your encrypted item, and that you can store in the DHT. So, and the idea is that everybody might have this encrypted data item, but only the privileged users can encrypt the symmetric key and encrypt with that the data that you wanted to give them. So to have the picture, so you take the object ID, you take the symmetric key and encrypt the payload. You have the list of privileged users, you get their public keys, you encrypt the symmetric key, this one, with the public keys, and you append it to your encrypted item so that you have a list, and that at the end you sign. And with the signature, everybody can verify that it's your data, and only the authenticated users can decrypt the shared item and see what you wanted to send them. So the benefits are really it's replicatable, and the storing node cannot read the data. In the security lecture, we also saw that it's very performant, so its overhead per message for secure communication is only around 2 kilobytes. Cryptographic delay is 10 milliseconds, and with the overhead for access control, that's also very where is it? It's over here. So it's also very relatively well performing. Okay. Also with the aspect of monitoring that is included in Live Social, I just want to show some words how this can be really used in practice. So it really helps to, so here sky.com was used to monitor the CPU and bandwidth usage, the retrieval delays, the messages sent, number of peers, the objects in cache, and all that, to create statistics on it, and especially no personal information. So it's really not displaying any personal information on any user to the service operator. So you can see the number of nodes in red and the disk space usage in green, or here the bandwidth usage. And it's very helpful. So there was once a test. testing live social with 30 nodes and the dynamic node count. So this was the number of nodes that was monitored. So first it rose to 10 and then it went to 20 and then to 30, and one could see, for example, how long in general the nodes are online. And it's not very, so just to show what everything you can measure. So also message overhead over time, how many messages per second were sent, how many how the traffic varied over time, the storage, the free data disk storage, the used disk space was also measured, or the bandwidth consumption was measured. So you can really measure a lot of statistics about the performance of live social to identify where, for example, performance leaks are. Okay, so this was basically the core framework that's independent of the social network. And then for the social network, you have the several plugins that communicate either with the storage or over a message with each other. There are some mandatory plugins, like which every plugin might assume, like profiles or friends list or albums or chatting. So some very mandatory. And then you have these optional plugins that are not assumable. So some of the nodes have it, some of them don't have it. And the idea is that with these plugins you can really create this very rapidly new applications in a Unix style reuse of components. So if you know which plugins are available, then you can really reuse and recombine their functionality to create new plugins, new functionality. And there you have really a Unix style plugin environment which runs on a total distributed peer-to-peer plane. So at that time, I think that's from 2010, there were several plugins just to finish it up. So login and profile and friends and groups, search for some persons, photos, messaging, live chat, and multi-chat with several users. So that was also using a multicast plugin or shared whiteboard. And these are the graphical user interfaces. So you see, you can really create a large number of plugins and recombine them. And this is in contrast to SafeBook, a different philosophy. So it doesn't aim strictly on social networks and tries to create the peer-to-peer framework in order to just support social networks, but it aims at a more general framework and the general set of plugins. And yes, here you see again every plugin has its individual view and can be arranged. Okay, so current steps. So what are currently happening? What is about this currently happening? So first of all, there was in this year a distributed framework project group on extending this on distributed framework for social networks. So their goal was to finalize peer-to-peer framework and to add novel applications to it. If you are still looking for a project group for this summer semester, there's a new project group starting. It's called Peer-to-Peer Framework for Social Networks. You can also visit the website, and we are still working on it to extend it, the functionality both for the peer-to-peer framework core, so the main mechanisms, but also for the plugins. And there will be a presentation of the CeBIT at the CeBIT 2012. And if you're interested in seeing the results of the PG, I also have some tickets here with me. So if you want to have a look at it, just come after the lecture to me, and I can provide you some entry to see the results of the project group. And what it also helps in is to really create a general framework for in open source manner to create various applications in a peer-to-peer manner. Let me just see. Okay, to summarize, online social networks are very popular. So I think that's something that you also know. So billions of users using it, and really a biggest trend nowadays in the internet. And both for the user behavior, one needs sufficient matching solutions, but also that solutions needs to be secure. And one approach to meet the requirements of the user is to make it decentralized and to reuse these social interactions and social contacts to support them. And using peer-to-peer is a good approach because there are so many users, and typically these social networks do not consume so much resources. So even if you look at the one album size or the biggest amount one user could demand for his own profile, it's not beyond 10 megabytes, for example. So it doesn't need too much resources, and the users offer with their online time and with their devices lots of resources so that it can be operated. Still, it's challenging to design and to implement, but there are a few real approaches to decentrally implement it. Okay, so very last aspect of this lecture. So where is peer-to-peer going to? What is the future of peer-to-peer? So first of all, I think peer-to-peer is still remaining. It has to find some legit business models. So there has been file sharing where you really exchange mainly illegal data, and this is working, so everybody's happy with it, so at least the users, and they don't have to pay. But if it really turns into a commercial service and there are some other providers in a centralized manner, typically the users shift to the centralized approach because the real business models for peer-to-peer is missing. So why should users use peer-to-peer? First of all, one approach could be for backup and archival systems for individuals and corporate sorts of companies. That could be a business model. So Voila is aiming at this to really maintain your data securely. Also, there are some approaches for legal content distribution networks, for multimedia content, software updates, so to use BitTorrent to really exchange data in a legal way. Skype is one legal business model, and probably also some collaboration group and social software also saw where users in small groups, at least 10, 20 people, can share their data, and it's not really complex to set up those groupware. For the future, however, one potential I see is, of course, online social networks using a peer-to-peer infrastructure, because there you really have sufficient number of users, and that could be made use of. And there are also some trends which say we do not have to see it beside each other. So it's not peer-to-peer, client-server, and cloud, but they also might coexist. So it might be cloud-supported peer-to-peer or peer-to-peer supported client-server. So the approaches might coexist and use the best parts of every solutions to create a new common solution. Some might say it's the end of peer-to-peer coming up, because for file sharing there is strict law enforcement and consciousness among users. They do not really want to use it for illegally, and there have been also alternatives, at least up to some few days ago. So up to them until Mega Upload crashed, mainly because illegal file sharing. So peer-to-peer was in a bad shape, but now again I think peer-to-peer will find some new users, and in general, so the problem with file sharing is anyway, so either this one-click hosters, which now themselves has some issues, or if you use still peer-to-peer for file sharing, then the network operators might also intervene, so they try to block traffic, and it might go in the direction of a traffic-based payment for the internet that we use. So there are also some trends in the US to break this network neutrality. That means that applications and providers who generate most of the traffic in the internet should also pay more for it. So this billing of user based on usage, that might come up. That's already in the mobile world existing, where you only have your fair flat rates, where you only might use up to 300 megabytes, for example. So that might come up, and there are also various security leaks through peer-to-peer software, which might put peer-to-peer in a bad shape. So all malware and Trojans are spread like that. And there was also the upcome of cloud computing, which basically addressed many aspects of the drawbacks of client server. So in the beginning, people always said client server is not scaling and it's very costly, but now with cloud computing, it's very manageable. Okay, so where to use peer-to-peer and where to not use it. So first of all, can we solve everything with a peer-to-peer approach? First of all, it's not clear. So it might be solvable, like social networks or something like audio or multimedia streaming. But the question is always, how is the performance and how good is the security? So it might be solved with peer-to-peer, but is it good? So do users really want to have it? And should it be always preferred when it's technically possible? That's also not a clear yes. It's more a no, because sometimes it's very costly and it's worse performing than a centralized solution, and that's why people would tend to use a centralized approach. And also with scalability, that was always also a motivation for peer-to-peer, that it's inherently scalable, but it's also the case for cloud-based systems or for centralized systems. So Google or Facebook, they all use centralized approaches, so it's if you have enough money, it works. And it also work sometimes better than peer-to-peer, so especially in terms of performance. So when should it then be used? First of all, if you don't have money and you don't want to spend money in maintaining the infrastructure. That's the case for file sharing, that's the case for Skype, where the service is for free. So if your budget is limited, then you could it could make economically sense to use peer-to-peer. Also, if there's a wide interest in it and the relevance, if you have a critical mass of users, like for example social networks, that where users contribute their resources, then it might also work. And also if the users trust each other highly, so if you do not have too many security risks, then you could also apply peer-to-peer. And the further requirements to use peer-to-peer is if there's not too much churn. So if you have the users only being online for 5 minutes a day, then it's probably not a good approach to use peer-to-peer, because most of the users will be offline. And if performance is still an issue, then peer-to-peer might be a bad choice. But if the criticality is low, so you do not expect good performance, like in file sharing and also in Skype, because it's for free, then it might be okay. And last slide, so that I found quite interesting, where the future of file sharing might go to. So I'm not sure whether you are aware of this kind of data sharing applications. So you just put a USB stick in the wall and it cannot be removed. And okay, so that's the last slide for today's presentation and today's lecture and the lecture at all. And don't forget the registration process for the lecture. So everybody who registered for a date for an examination date, please also bring me or the secretary of Professor Scheidler your registration sheet, and then I will sign it. And this is the approach. Okay, thank you very much.